First of all, thank you very much for joining and attending. I'm Przemek Siemion. I work at Banco Santander in Madrid as a lead for blockchain research. I've been active within the Enterprise Ethereum Alliance, co-chairing the core specification group, but also being a little bit active in the Trusted Execution or Confidential Computing group that has been led by JC, who's with us today. And the topic is a little bit an extension of our internal discussions about what to focus on. I want to pitch the case for using blockchain as a registry for confidential computing agents and the importance and the utility of it. So the agenda is simple. First, let's talk about digital trust. So trust in the context of our digital interactions. How much of a big deal it is there business to be made? Is this important, relevant to us? Then a few words about trusted computing, what it is, and why should we care about it? Which brings us to the case, the topic of the speech, the need and the utility of an on-chain registry for trusted computing agents. And finally, just for the record, the bits and pieces of work within the EA that we have done that are on this trajectory. So it all, depends or relies on this idea of digital signatures. When you are given a digitally signed document, you're actually given three things. It's the message itself, the document itself, the public key, and the signature. So the signature being kind of an arithmetic or mathematical riddle that you can verify, that checks out. So you get this triple, and the signature is only possible practically with the knowledge of the private key from which the green key, the public key, has been derived. But you, as the recipient of the message, you can verify that indeed the one who created, the one who has given you the triple, the one who created the signature represented as a log, must have been in a possession of the private key. Okay, so this is beautiful mathematics, but on the level of trust, having verified that the signature checks out against the public key, what have you learned? Where are you with your confidence? Thing is, you need to be able to relate somehow the key to the entity. You only are secure that the document has been signed by someone who you expect to have signed it if you are sure that the key belongs, the private key is in a possession of this entity. So how this could be solved? We could go for a registry, like everybody in the universe, or everybody on this planet has a private key and registered their public key in this registry, which is possible to look up. This has not happened for multiple reasons. We went for a different scenario. We went for hierarchy of entities that we trust, and actually there is just a handful, like 7 entities that we trust as the root of trust. And every digital certificate, every digital signature carries over to those entities. And their public keys, their certificates, you have cached locally on your machine. So this is nice because you don't need to go out and look up a registry. Nobody needs to maintain a huge registry. But there is a problem that it is actually a slowly evolving thing. So it leads to expiry problems. It leads to missing update problem. We all know this. We go to the internet and some sites are not available because the certificate has expired. This is the price that we pay for not having to deal with a registry, with a linear registry, but just, you know, having a hierarchy. And the important thing to know about this is that this verification of the entity that is behind the signature, we talk about digital signature, we think about a PDF document that has been digitally signed. But actually, what is way more ubiquitous and way more important is this verification happening in the background practically whenever you go to the internet. So on the left-hand side of the slide, we have a handshake of HTTPS, of TLS, the image, the icon I've taken from Red Hat documentation. And this handshake makes digital commerce possible. This handshake guarantees that if you go to Amazon, you are actually browsing Amazon store and not something else. And you know, just to have some numbers denominated in US dollars, after quick web search, I found this nice table. This is just e-commerce in the top 10 economies 3 years ago. And you see that it sums up to like, almost 26 trillion US dollars. This is just e-commerce. And then you have all the banking industry, then you have supply chain management. This is really hundreds of trillions in volume, all that secured by this handshake and by this discovery. Now, the fun part is I'm pretty confident that the data I got is from the United Nations website, because it was, I downloaded over an HTTPS connection, which has been secured by this exact handshake. But there is something that the Red Hat guys and many people discussing TLS are not really verbose about. So when you look at the back arrow from the server hello, server sends its certificate. And actually, the red bubble is the key point, and this the most important vector of attack and exploit, because it is up to the client to verify the certificate and to make sure that the server it's talking to is actually the server that we have meant to contact. And this goes to our, goes through the chain of certificates. This goes to the root certificates that we have cached on our machines or in our software. We may even not know, but operating systems like Windows, hardly anybody goes there and verifies which root certificates are there, but they are there. This happens. So as we speak, Web 2.0, hundreds of trillions are secured by this kind of trust. And let me introduce here the word attestation. So this is the attestation in the context of current legacy Web 2.0 e-commerce. Now, of course, question is, who's gonna guard the guardians themselves? So how do we trust those entities that are custodians of the root certificates? And is this a good business? A quick search in the internet, gives us, for instance, VeriSign is one of the known entities. You think about digital trust, you a little bit think VeriSign. So if we look at their quarterly income, first of all, it's nice. Second, it's steady. Third, can you see the COVID impact? Practically, you can't. Yeah? So it's a very stable business. It's a very simple business model. We are happy to pay because this underpins practically all the e-commerce that happens on the Web 2.0 today. Now, could things go wrong? Yes, they can, they could, they actually did. In the past, there were entities that were allowed as root certificate custodians, and their certificates would be incorporated into Mozilla, into Microsoft Windows. What I want to point out is how slow was the process of discovery and removal of those certificates. So all this, there is quite a lot of manual intervention. I wouldn't bet that you couldn't find those certificates in Windows 10 today, because there are actual reports from February this year. People still needed to manually disable them. Okay, so that's Web 2.0. Let me, as a side note, remind us that blockchain by design is different. Blockchain was designed by crypto rebels that didn't want any root authority. So the public key that is associated with, and the signature that is associated with a transaction, it's not verified against any external registry. The blockchain itself is the registry. Every asset is associated with the public key by the address of its wallet. And you send a transaction to blockchain, the signature will be verified against this address, which means that, in effect, blockchain as designed by Satoshi, so Bitcoin, Ethereum, are, in a sense, registries of public keys or associations between public keys and digital assets. Which brings us to, to Web 3.0. So if we now try to elevate from words, from statements to actions. Many people talk about Web 3.0. There are different ideas what exactly it means. Some people talk about Internet of Values. Some people talk about ubiquitous embedded artificial intelligence, about distributed applications and distributed organizations. One theme that is there is delocalized computation. So computation that is not happening on your machine, but is happening somewhere for you. We see this more and more with all kinds of software that I'm not going to name, but we know that we depend more and more on the computation that happens elsewhere. And this is both in micro scale, so for an individual, and for the whole organizations that are migrating their operations into the cloud. Now, does it need security? Does it need some mechanisms to reinforce confidence? Yes. And my prediction is that confidential computing, which we'll explain in a moment, is going to do to computation what VPN or TLS technology has done to communication. So delocalizing, allowing you not to worry about where the computation is taking place. So what is confidential computing? Confidential computing is a family of technologies which encrypt data in use while it's being processed. So actually what we are talking about here is protecting your data end to end, because it's already being protected in transport and at rest. Now we have technologies that aim to protect it also when it is being processed. And moreover, and this is just as important, confidential computing must guarantee the honesty of the processing. So not only the data must not be accessible to third parties, even if they have better physical proximity to the actual computer, but also we need to guarantee that the program that processes the data is exactly the program that had been agreed upon. There are different approaches to confidential computing. One that we have to name is multi-party computing. And this is when computation actually happens in many nodes, and every node only understands and executes a fraction of the complete task. This is very secure. This is quite inefficient. This is being used for instance, signing transactions, high value transactions in blockchain. All the crypto exchanges now are actually employing multi-party computing, signing signatures in some shape or sort. But this is okay for single signatures, but not for high volume tasks. So there is also a flavor which is hardware based, which is not as secure. There are known side channel attacks maybe, but it's very, very efficient. And when we say very efficient, it's like the penalty for executing it the secure way is less than 50% against the benchmark of unsecured processing. And don't quote me on those numbers, because we'll get into discussions with vendors, but this is more or less, the goal is, and the reality is, you can be very close, really below the factor 2 penalty for having your computation secure. Now that some critical ingredients, they need to be trusted setup. So we need to trust how this thing is actually organized, and there should be a way to verify remotely, because all this business is happening remotely. There must be a way to verify in a remote way that I'm actually interacting with a confidential computing agent and not with an imposter. Okay, so how do you go about it? Well, you need to encrypt your data somewhere, and you need to set up your parameters somewhere on this stack. There are slightly different approaches. Our thinking mainly, I think, has been influenced by interacting with Intel for quite a while. Intel has been an active member of the Enterprise Ethereum Alliance, and probably will work with them some more in the future. But there are different approaches. Could be like you look at IBM HyperProtect, and they put the whole thing into basically an HSM, so into a 360-degree security. The opposite approach is SGX, so software guards extensions from Intel that put anchor of the encryption inside the CPU. So the data is only decrypted in the CPU, and the side channel attacks would be to get a hold of the CPU cache. Anyhow, the goal is to guarantee that nobody messes up with your data and with your code. So the concerns are, of course, is the encryption really solid, and how are the keys managed and stored, and is the hardware really tamper resistant? But at least equally important, if not more, is the question, how can you establish, how can you trust an agent that is, halfway across the globe? And there are ingredients that come to this trust, which would be like secure build of your code. And so the code that is being executed becomes a contract. It's a little bit like a smart contract without blockchain. Because if we can't trust the code, we can't trust that the data is secure, because the code could have backdoors. Secure boot, so not only we put the right software on the machine, but also this is exactly the software that has been bootstrapped. And eventually, being able to verify this remotely. Where confidential computing is today, is this a reality? Just two pieces of news on this slide. First, National Institute of Standards is calling for comments on their recommendation for hardening infrastructure with trusted computing. This is quite new. Second, if you look at the members of the Confidential Computing Consortium, which I put on the right-hand side, you might be able to recognize some of the brands there. I'm very happy to see eea-eth there and JC representing eea-eth being with us today. So we are still very much in touch with this, but this is really happening. This is serious, and certainly this is actually going mainstream. So now, what is the typical use case for trusted computing? First of all, you set up your trusted execution environment, so your enclave, which is a process in itself that needs guarantees. Then you deploy, or during this process, you deploy the algorithm, the software that has been agreed upon. It actually rules, what kind of insights will be derived from the data and who can see those insights. Now, once you start the enclave generates a couple of keys or a set of keys, and it publishes the public key. So the mental model is that the enclave keeps its unique private key secret and only publishes the public key. And by doing this, what happens is that everybody using the public key published by the enclave can encrypt their data, and the data can only be decrypted inside the enclave. So I don't have to worry about the transport security too much, as long as I can trust the enclave. Because even if the transport is compromised, I know that I have encrypted my data with the public key of the enclave. It only can get decrypted inside the enclave. So, if there is an attacker in the remote computer center, I don't have to worry too much. It's always a matter of price versus security, but confidential computing should give me a good degree of confidence that against your regular raccoon, my data is protected. There could be actually even more involved or interesting scenarios when we process the data that is a combination, a consolidated set of data from two parties that don't want to share this data between themselves. There is a whole bucket of use cases there, ranging from AML to privacy preserving data mining to federated learning. The whole trick is that both the blue guy and the yellow guy have confidence that the data can only be processed by the program that is inside the enclave. And the results, the outputs of the process will be disclosed according to the rules that have been put into the code. So very interesting. Alas, let's come back to the basic issue of trust. So before, this is a nice story, but before I engage, I need to verify, I must be able to verify that I'm actually interacting with a trusted computing agent. Yeah, so I really need a mechanism to verify that it has not been substituted by some man in the middle, and that the keys that I'm getting are actually really coming from the enclave that runs the program that has been agreed upon, etc. Because if this chain of trust is somehow interrupted, the whole game is lost. And moreover, now with the eye on Web 3.0, can this assurance process work in an automated scenario? So can we make it fast? We come back to the certificates that go to the root, certificates that are cached on our machine, and we see that the processes there are actually slow. And the thing to notice here is that the actors of this process, probably on both sides, are living much shorter, are more ephemeral than websites and business entities. So the process that is okay for procurement on Amazon probably is not okay if we have an ad hoc enclave that has been spun interacting with I don't know, a mobile application. So we have a little bit of a problem. It would be great if we had a reliable, immutable, censorship-resistant registry. I think I can think of one. So what we are calling for is to use blockchain as a meeting point, as a registry that enables this chain of trust, so that we, instead of depending on cached certificates that necessarily would be slow and slow to maintain, basically, not difficult maybe, but it's a slow process and manual. If we could replace that by a registry that is available publicly, that provides us with permissioning, with traceability, with availability, this would be great. And blockchain actually fits the bill, because blockchain, when you think about registering and verifying a trusted computing agent as part of the business process, blockchain makes it actually traceable, and blockchain looks like has been made to facilitate this kind of handshaking. Moreover, with programmability, a lot of attestation can be, so a lot of verification that it's actual trust, that the agent that tries to register is actually, can be trusted, is confidential computing agent. A lot of that can be done on chain, possibly with the precompiles. We have started looking into this, but with that, the black guy on the left-hand side could actually be another smart contract. So with that, we could close the whole process within minutes, if not seconds. and make it fully automated. The EA, we have started working on this. We have looked at how we could facilitate this in the context of Ethereum. If you see like the life cycle here of this agent, this is registration, discovery, invocation, and obtaining results. If this reminds you of the original design for web services, this is no coincidence. And now we all know that with web services, the discovery story never happened. UDDI services are dead. They only survived like within corporations as a local bookkeeping device. So why this could be a different story here now for trusted services? My bet is because with blockchain, you can also include the payment in the whole sequence. So with web services, you needed to establish trust for the commercial side of using the service. You would need to establish some relationship with the entity anyhow, which defeats the whole purpose of automatic discovery. But here, the payment is actually possible. So this indeed is a different story, and this indeed can fly. There is a slightly different variant. So we've been thinking about two different scenarios, whether the results, or whether the signal of fulfillment of the computation happens on chain or off chain, not so relevant. The other part of the work that we have done at the EA would be looking at the precompiles that would be needed. And there is a proposal, needs some work and some determination to finish. It makes on-chain verification of attestation claims affordable. It enables closing the whole process on-chain. It's reasonably technology agnostic, I would say, especially considering how much input was given by Intel. So I think this is a very reasonable foundation to move on. So to finish my case, at the core, blockchain is a registry binding on-chain assets and digital keys today. And there are standards, so that we have ERC20 and we have all the derivatives. By extension, blockchain is becoming a registry for off-chain assets, like NFTs that represent often some object off-chain, but also baseline protocol that basically uses blockchain as a messaging layer, so maps on-chain transactions, on-chain events to off-chain assets. And there are standards. And with the story of Web 3.0, with the story of autonomous programs of the Internet of Things, blockchain will serve as a registry for these guys, and we need the standard. And I've been trying to show you that the trust is needed to the business. The demand is there. The volumes are interesting. And the final question is then, who do we think could and should maintain a blockchain-based registry for confidential computing agents? So whom do we trust? How to organize this? Because as usually, there is this issue of the root trust. So, okay, there is a registry. It's a smart contract. Now, who rules it? how we organize governance of that. So yes, this is my final slide. I do believe that the analog of Web 2.0 in Web 3.0, the analog to certification authorities would be smarter and more online registries. I think blockchain is tailor-made for this. But nobody knows the future, so let's see what happens. And with that, yeah, I would like to open questions. Okay, so there is a question. Can you compare and comment on secret network blockchain, which uses Intel Trusted Execution Enclave? Well, the honest answer is I can't, yeah, because I don't know enough about secret network blockchain. But the bigger answer would be, I think today's blockchains are islands. Today's blockchains are like internet in early 90s. So we have a global network of telephone lines, and we have wide area networks that carry more interesting use cases, but only locally. And we are up for some very interesting merging. This would be my comment on this. Has there been any work on using decentralized identity and verified credentials as part of the trust setup? Yes, of course. So these agents, for instance, are entities that you need to identify. So am I still being heard? Because I have some.
Yeah, you're being heard. You're good.
Oh, perfect. Yeah, because my corporate firewall tells me about some timeouts, and it is always scary. Okay, so indeed, decentralized identity is needed there. And when you ask a question, who is an actor? You see that these are actually automated actors talking to automated actors, but you still need accountability, which calls for some identifiers. So yes, not only the could be, but they are indeed essential for a trusted setup and for the whole game. But the relationship is manifold. Yeah? So you could also use confidential computing to establish some relations without compromising privacy too much, etc. So yeah, this is actually very much connected, but in too many ways to work out here and now. Any other questions or comments? I would call, yes.
I have a question for you. So you mentioned in one of your slides a precompile, right?
Yes.
And that you would validate, that would be used to validate the credentials, right? Could you comment a little bit on the, assume this became real and widely used scenario, what that would mean for the network as a public utility or a public good, versus the, it's like when you basically use it as a public registry of, non-small data, and what that means sort of like long term, or could mean long term.
Well, non-small. So, okay, we may worry about accumulating data, but this probably can be addressed with pruning to some extent, but the growing size of the world state, the data is an issue, of course, anyhow. But blockchain needs, or to put business on blockchain, you need a way to interact with off-chain entities, signals, processes. And this is problematic because blockchain by itself is only reactive. We have different patterns to manage this. I think very interesting problem is, of course, oracles, and to look at how Chainlink is trying to provide reliable information by managing a chain, a whole raft of providers of this information that need to agree between themselves. This is a complementary solution. You could do the same in a trusted enclave, but in essence, what Chainlink is doing is a multi-party computing of sorts. So it is not very efficient. So if you think about delegating some more complex tasks, and I would think the first use case maybe is actually cross-chain interoperability, so that so we see that we have now a business that happens across chains. We see that you have assets that are on one blockchain and stablecoin that is on another. You want to provide delivery versus payment. You have an issue. One business that solves this problem nicely is, for instance, Fortranix, Fireblocks, Fortranix as well, but Fireblocks, and very hot stock, but their secret sauce is actually using SGX, is using confidential computing to secure cross-blockchain operations. So I think I would rephrase your question, and because in a proprietary setup, it's already happening. So question is there a case for a public, for a non-proprietary, for a standard way of doing those things? And I hope so, yeah, because otherwise, we have another entity that aggregates too much.
Follow-up question to that. Would you say that really what you're relying on, the verification really could be done by the relying party, right? So as long as they have access to the credential with a timestamp, right? At what point in time this was supposed to be true? Isn't that basically what you need?
It's always a matter of trade-off. Yeah? So what we need is, if I may go to, there is a question of ZKs, but so when I look at this slide, it's about decoupling. It's about decoupling between the root of trust, the trusted setup, and the usage. And this decoupling may happen in many ways. This having cached root certificates is one way of decoupling that is very slow, but very convenient. Having direct interaction without any intermediary is very fast, but super inconvenient. You have to verify everything yourself. So I would say in this picture, using blockchain as an active verifying registry is kind of middle ground, that you can regulate. And when you ask, okay, so how much of a precompile we need? Well, this is to be gauged, yeah. But but using something like blockchain, which is a registry, but also a trusted execution environment of sorts, allows you to find, maybe to optimize, this decoupling. So usually these guys are successful that allow you to optimize. Okay, so another question is there a hardware VM which maintains ZK proof of its execution? How do we know that the trusted execution enclave actually executed the desired published program? Wow. There are many ways, yeah? So ZKs, the proof of correctness of computation is one way. You look at, so in reality, in real life, what happens today? You have ZKs, yes, but then you need to deal with Groth 16 or some other prover system, or advanced concepts in cryptography. You have IBM that basically gives you a completely protected virtual machine, physically protected. You have Google Cloud that you can request secure VM. And then, okay, so you have insight into the boot process. You have the ability to verify signatures of software that is being booted. You need to trust that the boot process is standard. But that's as much. So you need to trust that Google is not making an exception to make fool of you. You have Intel that actually anchors the trust in the silicon of the CPU. So you need to trust Intel at the end of the day, but because they produce those CPUs, quite a few of them, and they promise and they make guarantees about losing track of the details of your CPU, you can be pretty sure that the privacy, but at the end of the day, you are never completely sure. So always, that it's only a matter of how much confidence you buy for how much money and how much inconvenience. You need to trust them that the governments and other bad actors have not forced to put a backdoor inside. Yes, indeed. So it's always a matter of, but maybe we can cross-verify with different methods. In any case, what I'm trying to say is, once there is an agent that you can trust, if you want a dynamic situation when it's not like one entity that is carved in stone or in diamond, but it's more like real life runtime managed environment. So those agents are created as on demand. You need also a way to verify to some extent that they are genuine. So what we are calling for is quite like the TLS, but with replacing the root certificates that you cache in your system with a smart registry on chain. It's not completely bulletproof, but it is some way. Yeah, back to ZKs, yes? Yeah, well, ZKs are not without problems themselves, but yes.
ZKs are also not as efficient, right? I mean, you can substitute ZKs for TEs, but again, it's a trade-off.
Yes.
Right, and the question is, what you're trying to achieve. Again, it becomes dependent on the use case. As we all know, there's no one size fits all.
Yes, I would imagine, looking from inside, imagine that you're actually inside the blockchain and you look for trusted information, and your trusted information is Reuters. You can trust an address, which is like very binding, because okay, so I know that this address is controlled by Reuters, so this information has come from the owner of the key to this address, so this is Reuters, I trust this information. Think about an exchange rate. But if you try to introduce some intermediate layer, if, say, Reuters needs to be able to rotate their addresses without you needing to recode your on-chain business logic, you need some kind of registry. Yeah, you need some place where Reuters can tell you, hey, this is my new address, trust it. Yeah? So this is this kind of on-chain discovery or verification process that we are talking about. Any more questions? JC, I wonder what you think about this after all the work.
Yeah, on my side, I try to follow what are the last trends in the development and to gather how companies will start to implement that as close as possible to production products. So maybe I have a question for you. From your point of view, what are the factors still limiting the adoption at a larger scale? Although, are they more on the technical side or more on the political side?
It's even not political. I would say this is waking up to the possibilities, and I think this is actually happening. So I believe this call from NIST for comments is not an accident. When you look at the CCC members, you see quite a bit of players that are relevant in the blockchain space. So to me, it's the question really is this the right time to think about a standard? And when I see that we are talking about the same on-chain traceability, essentially the same in the context of oracles and in the context of cross-chain interop, I would say, hey, let's make it as standardized as possible. And with that, EA could be not a bad entity to run a test registry. I know that from private communications that CCC would welcome standardizing, smart contract interfaces to something like this, because they all cover different corners of this whole play field. So actually my answer would be, I think those obstacles are going away. Okay, so another question, new to the EA, can you direct me where this recorded presentation will be located for the future viewing? Brittany, I think, will propagate somehow the link to the recording, yes?
Yep, that's correct. We'll get it on YouTube and then send the link out.
At the EA YouTube channel, correct, Brittany?
Yep, that's right.
Oh, excellent. Okay.
Actually,
so I
would like one challenge to leave you with, right? And to think about. So it's like, do you really need a precompile, or do you just need a basically a resolvable anchor hash that allows you to resolve all registered certificates and a revocation list on chain?
there's no doubt that the precompile is a priority 2 thing. So is there a value in a registry without a precompile? Certainly, yes. The precompile also has the problem that it needs to be quite specific to the format of, you know, what kind of certificates are to be processed. So it is a longer story. I think it is as well worth playing, but if you tell me that, you know, the condition for having an on-chain registry would be to give up on the precompile, I would say, let's do it. Let's do it tomorrow.
I think it might just be you know, if you think about the crawl, walk, run approach, you know, I think the you know, thinking about limiting the on-chain footprint,
yes,
is and see how much mileage we can get out of that is probably the correct first step, and then see if what would be the additional value add of having these certificates verified on chain versus by the user.
Okay, well, you know, it's a very interesting and longer discussion, because as well I can see that you know, processing the certificates during the registration allows you not to, you know, to not store them, for instance. So you don't pay for the storage; you only pay for the payload.
Yeah, you can use IPFS, for example, as your storage.
Yeah, exactly.
It's your storage medium, right? It's like you just need to, the solutioning needs to, you know, it's like just needs to be a little bit creative to see how much, you know, how can we maximize the value with the least amount of effort. Also in terms of being able to implement that, because if we say, yeah, we want a public registry, that means we need to get that in as an EIP that needs to be deployed, and I would presume that would be sort of like extremely low on the totem pole of things to do for the core devs. That doesn't mean that we shouldn't drop in the EIP, but you know, to get things rolling, we might want to be you know, not go to Mars first, but you know, first land on the moon.
Andreas, you're already there, yeah. So you're already solving the practical side of. I just wanted to argue that we should follow you, basically.
Thank you. No, but it's like it is. These are the things we should be, if we're really, you know, I'm serious about this. These are the things that we need to think about.
Address.
Those are the hard questions we need to ask ourselves.
No, absolutely. You know how much effort it is. What it means in real life. It's like having bees. You know, unless you know what you're doing, you're not gonna have honey. You're gonna be bitten or stung. So yes, it needs to be considered, but honey is there. That's my call. All right. So if there are no more questions, thank you very much for attending, and have a great day. And let's see us on the next session. Thank you. Goodbye.